Thank you very much for the introduction. Well, I'm very happy. I'm not about you that you have to see my face quite many times in the conference. So today I'd like to talk about Ruby 3.0 and also what's going to happen beyond. The Ruby 3 is going to be available very soon. So first, Ruby 3. Every year we have a release on the 25th December, and this year as well. As planned, we're going to release the new version of Ruby. It's going to be Ruby 3.0. So it's going to be major version upgrade. So that's as planned. The initial idea was we're going to launch this in the year of Olympic. So that was 2020. But the Olympic itself, the Tokyo Olympic, was postponed until next year. But Olympic was not the major reason for us to plan for this timing. Well, some people say we should postpone our release also by 1 year so that it's going to be in the same year as Olympic. But after all, we decided to launch the new version this year as initially planned. So it's going to be in less than 10 years. So, but if something extraordinary things happen, we may have to reschedule. But most likely, we can launch the new version on the 25th December, as we do every year. So this 3.0, well, the current version is 2.7. So compared to 2.7, we try to secure good compatibility. But at the same time, it should be faster and also the better Ruby language. So these are our targets. And after the release this year, we will have 3.0, 3.1. So that's how we like to create the future of the programs. So first, I'd like to talk about compatibility. We like to keep full enough compatibility with the current versions. But of course, we have to fix some bugs. So after fixing bugs, there may be some changes. At present in the world, there are so many programs which were written with Ruby, and some of them rely on rather buggy behaviors. So that might require some fix. But most of the programs can operate as before on the new version, Ruby 3.0. The 3.0 will have many additional new functions, but we design in the way that they are compatible. And also, we made lots of efforts to make it faster. Performance is important. So when we had Ruby 1.9, we experienced some challenges regarding compatibility. And it took 5 years to fix the split in the community because of that lack of compatibility. So that happened between 1.8 and 1.9. I think it was 2007. In order to run the program on a new version of Ruby, the existing program had to be rewritten on many occasions. But you don't want to do that. Well, many people don't want to do that. That's understandable. So because of that, although the new version 1.9, 2.0 became available, many people kept using 1.8. And for those people, it took some 5 years to move into the new version. So during that period, those people who were using the older version did not have a chance to enjoy the new functions, new functionality of the new version. So that was rather unfortunate situation. And a similar situation happened to another language, Python. It's well known as Python 3 problem. The situation was a bit more serious because their community was much bigger than ours. It took 15 years to fill in the gap between version 2 and version 3. If you compare 5 years and 15 years, 5 years is better. But the difference is, as for the Ruby 1.9, well, it had the compatibility issue, but also it used the new virtual machine known as YARV. So compared to 1.8, 1.9 was much faster. Because 1.9 was faster, you think, well, it's a little bit more expensive, but it's much faster. So I think that we could give the benefit to the user. We could demonstrate that to the user, I should say. So I think the speed is quite important. But the Ruby, it's not so bad at present either. It's not so slow. And many developers are using GitHub. GitHub was developed on Ruby. Maybe not so much in Japan, but the service to create a store, web store, Spotify is quite well known. Again, Shopify was also created on Ruby. So Shopify and GitHub, the size of the site are biggest in the world, perhaps some of the biggest in the world. So Ruby has the capability or speed at least to run these sites. So if you have the micro benchmarking, Ruby may lose in some cases. But is it so bad that it cannot be used to create a web application? I don't think so. So it depends on how you create a web application. So I don't think there's not many people who say, I don't want to use GitHub because it's created on Ruby and it's slow. So, but still, there are lots of people say the Ruby is dead, Ruby is not so popular. Every time they're looking at some popularity context. I think it's the same situation over the last 5 years or so. But even those people who say Ruby is dead, they use GitHub and go to the Shopify. But then why some people say Ruby is not good? It's because of the micro benchmarks. So this is a software to measure some particular function, 100 loops and some certain computation to measure the performance. But when you talk about the speed of the language, those people tend to look at the micro benchmarking. But for us, it's a kind of the sad situation because what's really important is in a real world. But if people are concerned about the micro benchmark, so let's make some improvement as well. And then from 2.6, we have introduced Jit Compiler, just-in-time compiler. So it dynamically generates native code at the time of execution. And by doing this, it can speed the speed. This is a technique that has been used by Java for many years, and JavaScript and Smalltalk as well. So Ruby introduced mjit since Ruby 2.6 and also Ruby 3x3. That's a title. So Ruby 3.0, it's going to be a new release. according to some benchmarks, it's going to be 3 times faster compared to 2.7. And we use the benchmark called OptoCarrot. And according to OptoCarrot, it's going to be 3 times faster. But OptoCarrot is the family computer emulator. So it's like you like to see how quickly you can navigate the screen. But if you navigate the screen so quickly, you can't really enjoy the game itself, so it may not be so practical. But anyhow, even with Jit Compiler, not every application gets faster. And even with a Jit Compiler, Rails application does not get much faster. So compared to 2.6, we have the lots of improvement, but still the real-world application may not be so fast or not much faster, even with the Jit Compiler. But if you measure with a micro benchmark, you may see the speed is faster. So including virtual machine improvement, we have made many improvements. So for the future version 3.1, 3.2, it's going to be faster and faster. And also for concurrency, compared to the past, well, in fact, it was 1993 when I started to write Ruby. The number of the CPU per computer increased. Back in 1993, always one computer has one CPU. That's all, period. But in those days, the performance of the computer increased dramatically every year. So increase the performance. We simply bought a new computer. We didn't have to change a software at all. But that was a happy days, and happy days are beyond us. So for the current computer, their performance does not increase like 1.5 times or the 1 point something times every year. So the performance per core has reached the saturation level. So what we do is we increase the number of CPUs per computer. At present, there are multitask, accessing internet, the background, and then you navigate the screen on the front. So the multi-core is requirement. So this is the key to improvement of the performance. So we can say that we are now in the time of multi-core age. So dual core, having 2 CPUs, or octa-core, 8, or for server, 64 cores. So these have become the norm. So in order to improve the software performance, we have to think and how best we can use the multiple cores. But the performance of each core itself does not change so much. So we have to improve our software. And that is where the concurrency becomes the keyword. However, the Ruby at present, for security reason, has global interpreter locks. And this GIL is a stumbling block or limitation to the improvement of the performance. And that is why we decided to introduce a sync fiber and a Rakta. And by multiplexing the I/O, we can improve the performance. So async, await are keywords used for other languages, and also Node.js, Python, PHP. Async await is already used. So for JavaScript, they use the I/O with callback or with promise. At present, async await is very common approach So Ruby 2 has been using the blocking I/O.
In Ruby 3, fibers are used to make a synchrony. Fibers were present in the previous Ruby, so no keywords are added, which maintains compatibility. And we have context switch for each I/O. The scheduler can be specified to utilize those functions. And we're not using multi-core, but async fiber improves the concurrency. In order to use multi-core, we have to have Ractor. This is a new function introduced. Ractor stands for Ruby Actor. This is a coined word. There are many Ruby programs using the similar class names. We were talking about guild, but in the game industry people, the guild was frequently used, so don't use it. This is the message from the game industry people. We have isolated object space, and we communicate via channels. We don't share state. In reality, we have some sharing, but this is a limited sharing. More specifically, immutable objects which cannot be rewritten, and the deeply frozen objects are there, and class and module, these are the things we can share. And between the Ractor, there are no interlock. There are no interpreter lock, so we can utilize the multi-cores to the greatest extent. We want to improve Ruby better, and we would like to find errors and bugs as early as possible. And since 2010, static typing was added to GEM. And Ruby is a dynamic typing, and there are no static typing. And we were told that Ruby is an obsolete. And the recently popular language of Go, Rust, and Swift, those languages are static typing language, and they're popular these days. On the other hand, the other languages, conventional languages like PHP, Python, and JavaScript, has the static typing declaration so that they can look like the popular languages. So many of the modern languages, many of the popular languages go static typing to some extent. Then our rival languages go to static typing, and we wonder whether we should go or not. You know the answer. My answer is no, because Ruby is positioned differently from other languages. What we want is the precise checks. When we move to static typing, we can identify errors more at a faster rate. We have a less effort to identify errors. However, on the other side, since static typing is very redundant, we don't want to write it. Many of the TypeScript programming shows that we can do that extent, but we don't want to do that ourselves. There are two sides of the coins. We want to identify errors earlier, but we have to provide more information to the compiler to let them identify errors. It is not very rational, and so the Ruby signatures and type prof are introduced. to static type checking. The Ruby, this is the basic language to declare for Ruby programs. There is a soft of food, and without functions, we may be able to end the computations. And there might be some integers. Here, the Ruby 3 is attached with the standard template in the library, and the Ruby 3 ships with RBS for the core, and we have type checker to the Rubies, and IDE integration environment can utilize this, and IDE complete the code, and there are better code completion because the IDE can tell the programmer what to be added. If there was a type signature, whether there is an error in the typing, type signature pop-up is incorporated in the function. So this is a kind of an interactive system. Ruby signature is launched very recently, and we only have the prof type, but it opens the new possibilities. TypeProf is a tool to offer naive type checks, and after implementing, after executing the type check, RBS generation is made automatically. The type signature engine is not wise enough, so some of the things they may not be able to detect, but we have some prototypes, and we have sufficiently good prototypes. It will require a long description of the system, who is a class, and there is a method of bar and who. And for abstract interpretation technology, we can read it and we can have this, oh, there is no bars and I made a mistake. So bar is through the integer and foo is through integer. This is a prof type. Type prof, current type prof, if there is a sequence, the elements in the sequence are generic type or template type. And it is not something they can assume. So we have to write it, and we have to supplement the information manually. Anyway, in order to create better language, we are working on the field, in the field of static typing. And new syntax is added, like pattern matching or numbered block parameters. Pattern matching is this. For example, if the data is here, we would check whether the data agrees to the pattern. If there is a JSON, and if there is the name of is Alice and children's name is Bob, and if they are correct, it has true signals. And if we have a map made into twofold, the first parameter is this, and the second parameter is that. We can have the numbered block parameters, and these are the Ruby 3, which will be available shortly. Unfortunately, the new functions added to the new version are not used by many people, so some of them are experimental state. And as a result, we have to receive your feedback so that we can improve specifications and performances. There are a lot of opportunities to grow. It is, we ensure the quality as things which would compatible to 2.7, but some new features and some new improvement is to come. Ruby 3.0 is offered. Then what will happen after 3.0 becomes available? we have to improve the function so that it can be more complete. And several new features may be buggy. Even today, we have, working on the rectors, there are some buggy elements staying in the Ruby 3.0, but I want to work harder, and we would continue working to improve it. Then we have to improve the supporting tools. Not only the language called Ruby, but we have to have tools to support the language Ruby, like Solargraph or Sorbet. And for the code linker, we have RuboComp. There are tools available in Ruby. And these tools enable better utilization of Ruby. But we need more tools, like type checker, formatter, language server protocol, the better server, and performance tuning tools. There are many tools we need. And it cannot be done only by the core team. We have to support the team. And we want to improve the performance. Jit Compiler, the current Jit Compiler is not something satisfactory. Multi-layer JIT should be introduced. The Jit Compiler requires a lot of cost. So we have to have a lighter JIT so that we can have a multi-layer and lightweight JIT and mirror and other things should go. I have never made publication in Japanese language, but we are thinking of introducing static Ruby. Ruby is a very dynamic language. Dynamic typing and a dynamic class and metaprogramming allows us to change the program itself. They are useful, flexible, and powerful, but it is difficult to optimize the functions. It is still the very early stage, but we are thinking of having the static barrier. Beyond that barrier, the dynamic aspect of the Ruby will be limited so that we can have a faster processing. Like method redefinition is not a variable beyond the barrier. And we have beyond the cache and other method caching will work more efficiently. Another thing is the static interpretation. Interpretation of the code should be done on a static manner. More specifically, they say that they want to have a macro for Ruby. We may be able to offer some, and they can perform, we can reform AST. It's just an idea. But anyway, we will keep moving forward. Ruby is not dead. Ruby will not be dead. We are moving forward, and our supporters will move forward. And we would like to create better world with Ruby. And we want you to create better world. That's something we want to implement. So Ruby World Conference 2020, this is the keynote lecture. Ruby 3.0 and beyond is the title of my talk. Ruby 3.0 will be available shortly. And then after that, Ruby continues to develop. This is my declaration to end my keynote talk. Thank you very much for your kind attention.